Hi ladies and gentlemen, this is Mr. Green. This is another series of lessons for Algebra 2. We're going to continue looking at Unit 6, which is dealing with matrices and vectors and things like that. Okay, so don't forget quiz corrections. I do accept them. Due dates, things lock up. You don't want to have zeros in your grade book, so make certain you get them all taken care of. Okay, so 6.02, operations with matrices. We know what a matrix is now. We know how matrices work. And so what we're going to be doing is we're going to try to do some combinations with matrix and show you how we combine them together. So when we're adding and subtracting matrices, they have to be of the same size. So if you've got a 2 by 2, you can add that to a 2 by 2. If it's 2 by 2, you can subtract it from a 2 by 2. But you can't do a 2 by 2 and a 2 by 3. They don't work together that way. They have to be the same size of matrices. Now, what you're going to do is you're going to combine the elements that are corresponding. So these two A11 and B11 are going to combine together to give you A11 plus B11. And A12 and B12 are going to combine together to give you A12 plus B12. Okay? And that's how you're going to be combining them together. I think that if you see it in action, it might be a little easier. So if I've got A is this matrix right here, B is this one, and C is this one, and D is this one, we're going to actually perform some operations here. And you notice they're all 2 by 3 matrices, right? C is not. Can we actually combine anything with C? No. So we can't even do this one down here. Mark that one out because it's not a 2 by 3 matrix. So sorry, C, not the right size. You'll have to go somewhere else. Sorry. Okay? So if I'm adding A and B, 10 and 7 is going to give me 17. Negative 9 and 15 is going to give me a 6. 0 and 1 is going to give you a 1. 4 and negative 1 gives you a negative 3. Doesn't, gives you a positive 3. Okay? Negative 12 and 8 is going to give you a negative 4. Negative 2 and 5 is going to give you a 3. And that would be the combination A plus B. A minus B. So if I said 10 minus 7, I would get a 3. If I said minus 9 minus 15, I'm going to get a minus 24. If I say 0 minus 1, I get a negative 1. If I say 4 minus a negative 1, I get a 5. If I say negative 12 minus 8, I get a negative 20. And a negative 2 minus a 5 is a negative 7. That would be A minus B. Okay? So let's do multiple ones together, like in D here. So if I said A plus D, so 10 plus negative 6 gives me a 4, minus 7 is going to give me a negative 3. All right? So this was 10 minus 6 minus 7 is going to give me 4 minus 7 is a negative 3. Okay? So negative 9 plus 0 minus 15 is a negative 24. Okay? And 0 plus 12 minus 1 is going to give me an 11. You see what I'm doing there? You see how I'm getting those values in there? Okay? Go to the second row. We've got 4 plus 15, that's 19, minus 1, that's going to be an 18. If I take a negative 12 plus 8, that's going to be a negative 4. Minus 8 is going to be a negative 12. And if I take a negative 2 plus negative 4, that's negative 6. Minus 5, that's negative 11. That would be my resulting matrix. Ta-da! Done 3 addition subtraction problems, even a difficult one. Okay? You guys get how to do that, I hope. If you have any questions, make certain you're coming to tutoring, because that's where you're going to make certain you get it understood. Now, the absolute simplest thing you can do is multiplying a matrix by a scalar. Why? Because what you're going to do is you're going to multiply that scalar times everything in the matrix. What's a scalar? It's a number. Okay? So if f is this 2 by 2 matrix here, if I say 5f, I'm going to multiply everything in that matrix by 5. 55, negative 20, negative 10. That's how easy it was to do. I just multiplied the 5 times every one of those values. If I'm multiplying it times negative 3, it's going to be negative 30, negative 3, 12, 6. And that would be negative 3 times every one of those values in the matrix. Okay? Now, these are the properties of mathematics that you have studied in the past. You've studied the commutative property in the past, and that simply says that you can move things around and add them. You can do the same thing with matrices. So if you're adding a plus b, it's equal to b plus a. We've used the associative property in the past of addition, okay, where a plus the quantity b plus c is equal to the quantity a plus b plus c. That works. The associative property works for matrices too. The property of scalar multiplication, you can multiply a scalar times a is going to be equal to every value in that matrix times that scalar. Okay? Associative property works. You can switch them around. The distributive property works. You can use the distributive property with scalars and matrices, and it all works out very easily. Okay? The equality property says that two matrices are equal only if every one of their corresponding elements is equal. So these are all pretty common things that you might have seen before and understand. Those rules for mathematics, those properties of mathematics, you might need to understand them. Let me give you a real world situation, okay? Matrices shown below show baseball and football ticket prices in dollars for 2 years at a particular stadium, okay? These are the 2008, 2009 baseball prices, the football prices, and the different locations they were. It says write a matrix that shows the changes in prices from 2008 to 2009. 8 to 9. So they're wanting you to subtract them because it's the changes in prices, okay? So I want to take the changes in their prices. So I'm going to say 40 minus 45 minus 5. I'm going to say 100 minus 110 minus 10. I'm going to say 27 minus 30 minus 3. I'm going to say 85 minus 92 minus 7. I'm going to say move out of my way because there's something there in my way. Okay? 15 minus 15, 0. And 75 minus 87, that is 12, right? Yeah, minus 12. That would be the answer to A. Now, what can you conclude about the changes in ticket prices? You know what? I think the mezzanine has changed the least because, negative 3 and negative 7 as opposed to 0 and 12 or 5 and 10, right? I would say that all the prices have gone up in price. Why am I saying up in price? Because I was subtracting 2008 minus 2009. So the prices have gone up, right? 40 to 45, yeah, all the prices have gone up except for one. I would say baseball prices have changed a lot less than football prices. There's a lot of different things you can look at when you're looking at those matrices to see this. Okay? Now, suppose stadium management wants to increase all prices by 10% from 2009 to 2010. Well, what could we do there? we could say 1.1 times the matrix, right? Or that's going to be 45 times 1.1, right? That's going to be 110 times 1.1. That's going to be 30 times 1.1. That's going to be 92 times 1.1. That's going to be 15 times 1.1. That's going to be 87 times 1.1. That would be my matrices. Lost my 1 there. Okay? Does that make sense to everyone? So what do we got? 45 times 1.1, that'd be 45 and 4.5. That'd be 49.5. 110 times 1.1 would be $11 more. It'd be 121. 30 times 1.1, that'd be 33. 92 times 1.1, that'd be 101.2. Let's see here. 15 times 1.1, it'd be 16 and a half. And 87 times 1.1 would be 95.7. That would be the new ticket prices for 2010. Do you see how I did that? Okay. So here's a trick. I haven't started my calculator up yet, but I want to make certain you guys understand a couple things. There are ways that we can do this mathematics on the calculator. Okay? Calculator can be your friend. Okay? If you're having trouble with this, you can use your calculator to do some of the matrices type work. Okay? As you can see, my calculator is still starting. So hang on a second while I pause it. Okay, calculator finally started, so let me show you this real quickly. Right here above this inverse key, it says matrix. If you press second matrix, it gives you the ability to put matrices in here. All you gotta do is gotta go over to edit, like that, and press enter. It asks you how big of the matrix is. You key the values in here, and then you can do things like matrix math. Okay, let me get out of this real quickly. Okay, then you can do things like matrix math right here in the equation. So you could add, uh, you could say matrix A plus second matrix A, because that'd be the same size, and hit enter, and it will actually add the two together and give it to you this way. So it is one of those things that you can use this type of a system to help you, this calculator to help you. Okay? So having done all that, I want to tell you guys that I do appreciate you letting me know that you're in Algebra 2 when you send me K-mails. It really helps me keep my record straight and answer questions as quickly as possible. Okay? So I thank you for that. I look forward to seeing you next time.